Okay, so this is the first video in Unit 2, which covers free fall and projectile motion. And a lot of the stuff in this unit is just kind of a continuation of the concepts we learned in the first unit over kinematics. Okay, so this is free fall 2a. This section is related to the motion of objects in free fall and acceleration due to gravity problems. Okay, like usual, you'll take notes over this section, work on a practice worksheet, and then take a quiz over this section. Okay, so the first thing, just to kind of lead into what we're going to be talking about, is this question right here. Okay, and this is a true or false question. And the question says, heavier objects, and I'm going to insert a word here, always fall faster than lighter objects. Okay, so think about that. Is that true or false? Heavier objects always fall faster than lighter objects. And the answer to the question might surprise you. The answer to the question is actually false. Okay, now, if you said true, there's a reason why you might think that is the case, and that's because of what's called air resistance. And so when you drop an object, as it's falling through the air, it runs into the air particles, and it creates what's called drag or air resistance. However, in situations where you don't have any air, and that means you don't have any air resistance, it's actually not true that heavier objects fall faster than lighter objects. In fact, it turns out that all objects, regardless of how much they weigh, actually fall at the same rate, okay, as long as there's no air resistance to impede them. Now, I'm going to include links to these two videos here. If you want some demonstrations, one of the videos takes place on the moon, and one takes place here on Earth in a room where they remove all of the air from the room, and then they drop a bowling ball and a feather, and you can see they hit the ground at the same time. Okay, so as long as you don't have any air resistance, okay, then it's not true that heavier objects fall faster than lighter objects. When you remove that air resistance, you have what's called free fall. Okay, and so that is kind of a technical term, this word called free fall. Basically, an object that is in free fall means that it's an object that's falling only under the effects of gravity and no air resistance whatsoever. Now, air resistance can actually be really complicated, and so we're not going to really do problems too much with air resistance in this class. So most of the time when we're dealing with falling objects, we're dealing with a free fall problem. So, when you drop an object that's in free fall with no air resistance, the only thing making it accelerate, remember acceleration is how quickly your velocity is changing, the only thing making it accelerate is due to the effects of gravity caused by the Earth or whatever other planet you're on. Galileo did a lot of experiments dropping things off the Tower of Pisa, at least that's what they say, and he also thought that heavier objects fell faster than lighter objects, and it turned out when you remove resistive forces like air resistance, that actually turns out to not be the case. So all falling objects, as long as they're in free fall, accelerate at the same constant rate, okay, regardless of which one weighs more or size difference or whatever. If you dropped a peanut and an elephant on the moon when there's no air resistance, they would hit the ground at the same time. Okay, it's only when there's air resistance that the size or the weight actually makes a difference. Now, the acceleration due to gravity that we're going to use for Earth is we're going to use a value of -10 meters per second squared. And for acceleration due to gravity, we use the symbol g. Now, we could use an a because this is technically an acceleration. If you look at the unit meters per second squared, this is acceleration. A lot of people call it gravity, but it's really the acceleration due to gravity. And again, on Earth, we're going to use a value of -10 meters per second squared. Now, that is that's an approximate value. It's actually more like 9.8, and it actually changes depending on where you live on Earth. And so -10 is just the number we're going to use in this class just to make the math easier. Now, the 10 meters per second squared means if you drop an object, its velocity changes by 10 meters per second each second. The negative sign means that the velocity is going to decrease in the negative direction. Okay, so that's why that negative sign is there. Now remember, g is the acceleration due to gravity, not gravity. Okay, we talked about this before. When you have an object falling through the atmosphere, There's air resistance. That's not a free fall situation. That's a much more complicated situation that we're not going to talk about. So we're only going to deal with situations involving free fall, where we have a falling object and the only thing acting on it is gravity. Okay, that's a free fall situation. Now the reason we're only going to focus on these problems is because free fall is basically just a constant acceleration problem, because the acceleration due to gravity of an object in free fall is negative 10 meters per second squared. Okay, constant acceleration problems we've solved before in the last video and the last practice problem. Okay, so this is really an extension of what we've talked about before. Now, if you're a visual person and you want to visualize what that negative 10 meters per second squared means, this is basically an example. So let's say there's a girl on a cliff, she drops a ball. At 0 seconds, that means right when she drops the ball is at rest, and it has a velocity of 0 meters per second. She drops the ball, and 1 second later, the velocity is now 10 meters per second. 10 meters per second. Now, it would be negative 10 meters per second because it's falling down. After 2 seconds, it's now falling at 20 meters per second. So in other words, it's falling faster and faster and faster. In other words, the velocity is changing by negative 10 meters per second per second. Okay, so that's a way to visualize the acceleration due to gravity. Now there's two types of problems involving free fall. You have your basic free fall problems, which just involve objects moving up and down, straight up and down, one-dimensional problems. And you also have what's called a two-dimensional problem, or projectile motion problem. Projectile motion is something we'll talk about in the next section of this unit, but basically projectile motion involves an object that is moving, I don't know why this is upside down. Projectile motion involves a situation where an object is falling, it's in free fall, but it's also moving sideways. Okay, so in this picture right here, this red ball is just like in normal free fall, and this yellow ball is a projectile. Okay, this represents projectile motion. And again, we'll talk about projectile motion later, but there's lots of applications of projectile motion, like for example, baseball or soccer or basketball. When you shoot a basket, not only is the basketball falling, but it's also moving side to side, and so that's an example of a projectile. Okay, but first we're going to talk about solving problems, just normal freefall problems going straight up and down. Now, here are the equations we're going to be dealing with for freefall problems. Now, if you take a look at these equations, you should see that they look very similar to the equations we've seen before. Okay, the only difference is that we have replaced the a with a g, because instead of the acceleration being an unknown or a variable, the acceleration due to gravity is a constant. It's that negative 10 meters per second squared. So g has a constant value. Okay, besides that, the equations all work the same way. We've got initial velocity, we've got time. On your worksheet, you might see this labeled as dy instead of dx. The reason you'll see it as dy is because these objects are moving up and down, and so their displacement is up and down in the y direction as opposed to side in the x direction. Now, here are some facts you need to know about objects in free fall. If you look at this slide, it says what happens to the velocity and acceleration of a ball if it's thrown straight up into the air. Now, the acceleration of the ball as it goes straight up into the air does not change. This is a constant acceleration situation. The acceleration is always going to be negative 10 meters per second squared, as long as you're on Earth and as long as there's no air resistance. So the acceleration of the ball does not change as it goes up into the air. It does not change as it falls back down from the sky. The velocity of the ball, which has to do with how fast it's moving, does change. So if you imagine taking a ball in your hand and tossing up into the air, as it goes up, it's going to go up, but it's going to slow down. It's going to go slower and slower and slower, and eventually at the highest point, it's going to stop moving, and then it's going to turn back around and fall back down towards you. Okay, so the velocity definitely does change, but the acceleration does not. Same thing when you drop a ball. When you imagine taking a baseball in your hand and just dropping it, when you drop it, at the beginning, it's not moving, right? Because it's just sitting in your hand. And so the velocity is going to start off at 0 when you drop it, and the velocity is going to increase, or I guess I should say decrease because it's going in the negative direction. as it falls down. The acceleration of the ball is not going to change because it's constant downward acceleration. Okay, so just keep that in mind. We'll do some problems with these equations using those context clues I gave you. Okay, so let's take a look at an example. Example 1 says Anna dropped a rock from the top of a 60-meter high bridge. Ignoring air resistance, how long did it take for the rock to hit the ground? Okay, so the first thing you want to do in any kinematics problem is identify your given information. Now this is a little bit trickier because you have to use some context clues. For example, the first context clue I'm going to use is the fact that Anna is dropping the rock. We talked about this 2 seconds ago. When you release something, when you hold something in your hand and you hold it out and then you let it go and you drop it, it starts off with a velocity of 0 meters per second. So when it tells me in the problem Anna dropped a rock, that is a context clue telling me that VI, the initial velocity of the rock, is 0 meters per second. Okay, now 60 meters is displacement. Look at the unit. That means it goes down 60 meters. Now here is another really important thing to watch out for. I'm going to label this dy. D for displacement, y because it's up and down. However, I'm not going to write 60 meters. I'm going to write dy equals negative 60 meters. Now you might ask, why do I write that? Well, because if you think about the rock, it's going 60 meters, but it's going 60 meters down because it's being dropped. Okay, and so the negative sign is important there. Now the question says, ignoring air resistance, how long is always a question about time, did it take for the rock to hit the ground? Now if you're looking at this, you might think, wait, we don't have enough information. Don't we have to have 4 things? Well, remember, in a freefall problem, you automatically have the acceleration because it's a constant acceleration due to gravity. And so we also have the acceleration g equals negative 10 meters per second squared. Now, how do I know which of my 3 equations to use? Well, I only have one equation that has these exact 4 things. So I want the equation that has g, vi, d, and t in it. And that equation is the one that looks like this. dy equals vi times t plus 1/2 gt squared. Okay, the equations were on the last slide of the PowerPoint, so go back and look at the equations if you need to. Okay, so once I have my equation, I'm going to plug in and solve just like I've done before. dy is going to be 60, actually negative 60, so I'm going to plug in negative 60. Make sure you don't plug units into the equation, otherwise it's going to get too complicated. So dy negative 60 equals vi, the initial velocity, is 0, times t, which I don't know t. Luckily it doesn't matter though, because 0 times t is just going to be 0 anyway. Okay, so I'll simplify that in a second. Plus 1/2, g is negative 10. Remember, that's the acceleration due to gravity. And then I have t squared, which is my unknown. Okay, now I'm going to simplify this. Negative 60. 0 times t is just going to be 0. So I have 0 plus this mess over here. I'm not even going to write the 0 just because I don't need to. And so negative 60 equals 1/2 times negative 10 times t squared. And I can simplify that a little bit more because I can just do half of negative 10 is negative 5. So how do I get t by itself? I ask myself, what is being done to t? Well, number 1, it's being squared. Number 2, it's being multiplied. And now I'm thinking I have to do PEMDAS backwards. Okay, so PEMDAS backwards, I don't have anything to subtract. I don't have anything to add. I don't have anything to multiply, but I can divide. And so I'm going to divide by the thing that's multiplying my t squared, which is negative 5. Okay, so I'm going to divide both sides by negative 5, because that negative 5 is multiplying t squared, and I want to undo that multiplication. Okay, so 60 divided by negative 60 divided by negative 5 is going to be a positive 12, and that is equal to t squared. And then to finally answer the question, I need to take the square root of both sides, and so I just type in the square root of 12 into my calculator, and I get 4.6 seconds. Okay, it's really important that you pay attention to your negative signs, because if you had put 60 and not negative 60, then your calculator would have blown up. It would have said like no real answer or something like that. Okay, so this had to be a negative 60, otherwise you would get the wrong answer. So that is example 1. Okay, pause there if you need to take a look at that some more. Okay, so let's do 2 more quick questions. Okay, example 2. It says a ball was thrown straight up with a velocity of 15 meters per second. Okay, as I'm going through, I notice it's being thrown straight up. This is the velocity that it's thrown up with, and so this is going to be my initial velocity. I'm going to label that VI. What is the maximum height the ball reaches? So this is actually telling me 2 things. First of all, and I said this a few minutes ago, but when you throw an object up into the air at the highest point, what does it do before it starts to come back down? It actually stops moving. And so when it says maximum height, that is a context clue. That is telling me that at the highest point, the velocity is going to be 0 because it's going to stop moving before it comes back down. Okay, so that tells me that V final is equal to 0 meters per second. Plus, the question itself is asking me for a height. Now, how do you measure height or distance? Well, that's going to be in meters. So this question is asking me for dy. Okay, so if you want to know how high something is, you're looking for displacement. Okay, so we're looking for dy. Now, again, because it's a free fall problem, we also have the acceleration due to gravity. G is negative 10 meters per second squared. And so now I want to use the equation that has V final, V initial, D, and G in it. And the equation I'm going to use is the one that looks like this. Vf squared equals Vi squared plus 2G dy. I'm going to plug in my givens into the equation. V final is going to be 0, so that's 0 squared. V initial is 15 squared plus 2. G is negative 10. And then dy, I don't know what dy is, and so I'm just going to leave dy in my equation. And now I just need to simplify and solve. Okay, so I'm going to simplify this and then do a little bit of algebra to rearrange and get dy by itself. So I'm going to do 0 squared, which is 0. 15 squared is going to be 225. Plus, now it's really important to remember you cannot combine this 225 with this number in here. This number right here is a coefficient for this variable. Okay, you cannot add apples and oranges. Just like, 2 plus 2x is not 4x. Okay, you cannot add a number and a coefficient. Okay, so 225 is being added to 2 times negative 10 is negative 20 times dy. And again, you cannot combine this 225 and the negative 20. That's not how algebra works. So from now, I need to rearrange this. I say what's being done to dy. Number 1, it's being added by 225. And number 2, it's being multiplied by negative 20. Okay, so I'm going to do PEMDAS backwards. And the first thing I'm going to do is I'm going to subtract. And I'm going to subtract to undo this addition. And I'm going to subtract 225 on both sides, just like this. 0 minus 225 is negative 225. And I still have this negative 20 that's multiplying my dy. Because it's multiplying, I want to undo that with division. So I divide both sides by negative 20, like this. And I get my answer. And I'm going to write it right here. Okay, I'm going to type in negative 225 divided by negative 20 into my calculator, and I get 11.25 meters. Okay, and so that is the answer to my question for example 2. Pause it there if you need to take a look at that. Okay, we're going to do one more quick example. Okay, example 3. A small boy drops his toy cart into a well and hears a splash 2 seconds later. Approximately how high is the well? By the way, it's kind of cool to me that you can figure out how high a well is just by dropping something and timing how long it takes to hear a splash. That's always like really interesting to me. Next time you're on a bridge or over a well or something, if you want to know how high it is, you can just do this really easy calculation. Remember, if something is being dropped, okay, that's a context clue. We talked about that before. Something being dropped means it has an initial velocity of 0 meters per second. He hears a splash 2 seconds later. Remember to pay attention to units. Seconds is going to be time. So 2 seconds, I'm going to label that t. And a question about how high, remember height is displacement. Okay, that's going to be dy. That is my unknown. And then I have g, the acceleration due to gravity, negative 10 meters per second squared. So I want the equation that has t, vi, g, and d. And that's going to be the equation, we used this equation a few minutes ago. It's the equation that looks like this. Okay, actually, sorry, this should be g. dy is my unknown, so I leave that in. vi is 0 because it's being dropped. That's why vi is 0. Okay. And it's really important that you understand 0 times 2 is just 0. And so in a second, the 0 times 2, I'm going to get rid of that because it doesn't matter. So here's my equation. I want dy. I simplify. 0 times 2 is 0. I could write 0 plus whatever, but I'm not going to write that because it's not important, because 0 plus anything is the same number. I can simplify this 1/2 and this negative 10 to make negative 5, and then 2 squared. And then all I have to do is type that into my calculator. 2 squared is 4. 4 times negative 5 is negative 20. Now, this is almost the answer to the question. It is true that displacement is negative 20 meters. However, height cannot be negative. Okay, height cannot be negative. So the displacement is negative 20 meters. How high is the well? Okay, well, if it goes down 20 meters when we drop it, that means the height of the well is positive 20 meters. Okay, so watch out for that sign change. Okay, so remember, displacement can be negative, but height cannot be negative. Okay, and a lot of the time you have to just kind of think about the negative sign on your own. Okay, so hopefully that helps. Pause it here if you need to look at that. Okay, this is just kind of a summary of the context clues we talked about before, and hopefully that gives you a good place to start to work on your practice worksheet. Remember, you can always look at this YouTube video by accessing my YouTube playlist that's available to you on Canvas at the very top. If you have any questions, please send me an email or come see me in Zoom. And as always, I will see you guys in the next video.